Hello everyone. I want to talk about how to sketch rational function with oblique asymptote today. Let me make a share screen. Here, whiteboard. I'm looking for my pencil. Here, let us talk about, I don't know why, every time when I record this video, I have running nose. Okay. Here, sketch the graph of f of x equal to x squared over x minus 1. Okay. We learned how to sketch, how to draw the graph, rational function from the pre-calculus, right? But then we're going to add the Calculus1 stuff, which is first derivative test and second derivative test. All right. So step one. So what's the domain? We're going to find the domain. We're looking at the function. Then every x values is okay. So all real numbers, we denote real numbers like that. But except the denominator is not equal to 0, right? So then x equal to 1. So when x equal to 1, we have undefined, right? So let me make an add set notation, x such that x cannot be equal to 1, okay? Now step 2, find intercept. Then for y-intercept, okay, we set x equal to 0. Then let me write down the function notation f of x as y equation notation. Okay, then we plug in x equal to 0, so we have a 0 squared, which is 0 over 0 minus 1. Okay, I almost say the negative 1. It's not, it's 0, right? Then we have 0 and 0. Okay, for x-intercept, set y equal to 0. Then we set 0 for y. Then x squared over x minus 1, right? We have a rational function. We want to find the x, right? Then we multiply by x minus 1, both sides. Then this is simplified, cancel out each other, okay? Then we get 0 left side equal to x squared, okay? We take the square root of both sides, but we don't need, this is 0, right? So x equal to plus minus in general, right? Plus minus square root of 0, which is 0, okay? Now, these steps, we don't need that, okay? Because anyway, the left side is 0, okay? So what I wanted to show you, the algebra steps. All right, then x-intercept, y-intercept, we have same order pair, which is 0 and 0. X and y. Okay, now step 3. We're gonna find oblique asymptote. Oblique asymptote, asymptote. some other book indicate slant, right? This oblique asymptote or slant asymptote looks like this. Y equal to mx plus b form. Okay, then you might forget the pre-calculus stuff. Oblique asymptote exists when the degree of numerator is greater than the degree of numerator. Let me write down for you. So oblique asymptote exists degree of numerator is greater than degree of denominator. Then how much greater? 1 degree, okay? It's 1 degree. Oops. Greater. So 1 degree. So we talk about the polynomial rational function, okay? 1 degree greater than the denominator, then there is oblique asymptote exists, okay? Then same degree, there is a horizontal asymptote, right? And the degree of numerator is less than degree of denominator, there is a horizontal asymptote as well, right? Maybe in the future, let me make a video for asymptote as well. Okay. Now, since they talk about the degree, right? Oblique asymptote cannot exist with horizontal asymptote. Okay. Either way, oblique asymptote exists, then there is no horizontal asymptote exist. If horizontal asymptote exists, then there is no oblique asymptote exist. Make sense? Okay, so let us do this one. Let me erase this one. So wait. So here, so numerator has x squared, denominator has x minus 1, right? Degree 2, right? This is degree 1. Okay, 1 degree higher than or greater than the numerator. Degree of numerator is 1 degree higher than or greater than the degree of numerator, right? But then how do we find the oblique asymptote, right? So we're gonna use polynomial long division. Okay, then, so you might not remember, it has been, sorry, it has been long time, right? So let me do, so algebra class, I'm teaching this way. What do you get this one? This is x, so this will be quotient, okay? Then now we multiply first term, which is x squared, and second term is minus x, okay? But then look, there is no x term, so I want to write down here 0x term, okay? Now, we must subtract all the time Okay, and parentheses, don't forget, we have a parentheses. Okay, it's a 5 stars. Then we have, it's a positive x for the remainder, right? All right, so then think x over x, right? We still keep doing until we get the 1 degree less than the denominator. Then we get 1, right? So we're gonna make a +1. That's constant term. Now we multiply again. First term, which is x. Second term, which is -1. We do subtract. Then we get +1. This is the remainder. I'm doing this one because you might not remember. Okay, from algebra course. So then, how do we write? We write this way. We write x + 1 is a quotient and remainder, which is 1, and then denominator, which is x - 1. Okay, this is a pre-calculus stuff, right? We did that, but then calculus 1 stuff, how do we determine 1 over x - 1 there? Okay, because oblique asymptote has the form of y = mx plus b form for oblique asymptote, right? Then let's take the limit for this one, okay? When x approaches to, okay, let me write down this way. Limit, take the limit. X approaches, something. Voice is, x approaches to positive infinity, okay? 1 over x - 1, okay? When x approaches to +1, positive infinity, okay? Then this one approach to 0, right? Because think 1 over x. 1 over x looks like that. When x approaches to positive infinity, okay, the y value, the graph, approach to 0, right? Same as we take the limit. Then 1 over x - 1, okay? Then when x approaches to negative infinity, okay, I'm using, maybe I should use the yellow one, okay? Then what's the graph? The graph approaches to 0 as well. Can you see that? This graph, okay? So this will be 0. So we have this term, everything. I'm circling here. Okay. This is 0. So this will be y = m, not m, y = x + 1. will be oblique asymptote. This is a straight line with a dot line, right? We know how to draw. Okay, x plus 1. Now, let's move on. Okay, how about vertical asymptote? So there is no horizontal asymptote, right? I said earlier, if there is oblique asymptote exists, then there is no horizontal asymptote. Okay, then let us check vertical asymptote. Okay, so, oops, top. What's the definition of vertical asymptote? Let me write down. When denominator is 0, right? So we normally say that when denominator is 0, undefined, right? When undefined, then vertical asymptote exists, right? So it looks like that vertically, okay? So then we knew that in the domain, when we found the domain, right? So x cannot be equal to 1, right? So there is a vertical asymptote. So looking at the denominator is x minus 1 equal to 0, then x equal to 1. This is a vertical asymptote, okay? Now, we want to know about the behavior about the graph, nearby asymptote. So how they indicate? So they indicated as, take the limit, x approach to 1 from the right, okay? Then x squared over x minus 1, okay? Let me give you a hint here as well. Okay, 1 approach to from the right, right? So this means, okay, think 1 point, let's say that 0, 0, 1, or 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. It's up to you, okay? Slightly the right side, okay? Then you plug in. So 1.001 square and 1.001 minus 1. We don't have to calculate. We can just check whether it is positive or negative, right? This is positive, right? Okay, it's more than 1. We take away, subtract, it's positive. So nearby vertical asymptote, positive means it's a positive infinity. Okay, let me write down nearby vertical asymptote. Okay, let us check. Take the limit, x approach to 1 from left. Okay, x squared over x minus 1. Okay, now 1 from the left means about 99999, 999 or 9999 or 9999999, right? Then we plug in. Okay, so plug in 0.999 square over 0.999 minus 1. Okay, so we don't have to calculate. We just notice that there is negative, right? So negative means nearby vertical asymptote. Okay, that means negative infinity. Okay, So we should remember this one from the right. So this means, let me write down, let me draw quickly. So 1, so this is 1. So we have a vertical asymptote there. Then we don't know how it looks like this one yet, but then from this one, from the right, something positive, go to the positive, right? From the right. From the left, something goes to negative, like that. Right? Okay. Let me erase this one. Okay. Now, calculus stuff. So step 5. We're gonna find the first derivative. Then we set equal to 0. Then we're gonna find the critical point. Okay. Find the critical point. Okay. What was it? We have the function, which is x squared over x minus 1, right? We're going to use the quotient rule. Oops. So this will be f g quotient rule formula. F prime g minus f g prime over g squared. Okay. I want to do order this in this order because it's easily to remember. All right, so f prime, what do you get? So f prime, which is 2x g minus f, which is g prime, which is 1, right? If you want, you can just write down. G squared, which is x minus 1 squared. Okay, so that is 2x squared minus 2x minus x squared over x minus 1 quantity squared, right? Then this will be x squared minus 2x. Okay, now we set this one equal to 0, solve for x. For critical point, right? So then, since the right side equal to 0, we not really need multiply by x minus 1 quantity squared. I said that in the beginning, right? We don't need that step. So x squared minus 2x equal to 0. Okay. And also, we know that critical points when exist when f prime is undefined, right? So critical point so when f prime undefined and also when f prime of x equal to 0, right? So two cases, we can find the critical points. But in this case, looking at the denominator has squared, okay? We never get the 0. So there is no exist, f prime is undefined, right? Then we're gonna find the critical point, just solve for x. So here we factor out x minus 2 equal to 0. Then x equal to 0 or x minus 2 equal to 0, that is x equal to 2, okay? So there is 2 critical points in this function, 0 and 2. Now we're gonna do sign analysis. So let me erase this one, 0 and 2. Step 6. Sign analysis. Missing. So we have 0 and 2. Okay, but then we need to consider there is a vertical asymptote, right? So there is a vertical asymptote at 1. We know that, what was it? Left side, right side. Left side is going to negative infinity, in this case, right? Nearby that. And then from the right, going to the positive infinity. Remember, we did earlier. All right. What do you want to pick between the region, negative infinity to 0? Okay. What do you want to pick? 0 to 1. What do you want to pick? 1 to 2. And what do you want to pick? 2 to infinity. You can pick any number between there. Let us do sign analysis. Okay, so let me just follow here the book. So pick what do you want? -1, always easy. -1, +1, 0. So x equal to -1. And f prime of -1. So we had x squared minus 2x over x minus 1 squared. Then x minus 1 squared, okay? That is, we plug in -1 into x, so -1 minus 2 over -1 minus 1 quantity squared, right? All right, so we don't have to calculate. So we're gonna just do sign analysis here. So parentheses numerator is a negative. Negative times negative, which is positive. Denominator, every time is a positive because it's squared, right? Which is positive. Okay, so here positive. What do you want to pick between 0 and 1? It's obviously 0.5. So 0.5, which is 1/2, right? So let us do that. So positive 0.5, 0.5. So which is negative numerator and 0.5. The denominator always positive. I said earlier. So this will be negative. Okay. Now, between 1 to 2, what do you want to pick? 1.5, which is variable 2. So 1.5, it's negative, and the always denominator is the positive. It's negative, so it's a negative. What do you want to pick between 2 to infinity? Let's see. Pick the 3. Okay. Then pick 3, 3, positive, positive. So it's positive. Okay, so first derivative is telling us when the sign analysis goes to positive, negative, and there is a local max. Sign changing from positive to negative, right? Positive, negative, there is local maximum. Sign change from negative to positive, that means negative to positive, so there is a local minimum. Okay, then let me write down here. So positive to negative, so there is a local minimum. I mean the positive, negative, so oops. So this will be this line. Okay, this one 0, 0 is local maximum. And 0 to 1, 1 to 2, there is no change, sign changes, right? So we cannot say anything. And then 2 to rest over, there is negative to positive. So negative to positive, there is a local minimum. Okay. Now, if we plug in f of z, original function, it's x squared over x minus 1, then we get 0, right? So when x equals to 0, we get y equals to 0 as well. And f of 2 squared over 2 minus 1 is 4. So 2, 4. So local maximum at 0, 0, local minimum at 2 and 4. Okay, so we're gonna draw that later. Okay, we do second derivative. It takes a long time, huh? So let us do this. There was a step 6 and step 7. Step 7. So we're gonna find the second derivative, and then we're gonna, what's the second derivative test is telling us, right? It's greater than 0, less than 0, right? And that means greater than 0, then concave up. Second prime is less than 0, it's concave down. That's why we know how to graph their shape, right? Up, down, like that. Okay. Let's find. Check. So second prime. So I need the first derivative, right? So let me write down first derivative, which was x squared minus 2x over x minus 1 quantity squared. So we're going to use a quotient rule again, f over g, which is f prime g minus f g prime over g squared. I have to be careful. So f second prime, f prime, drop the power, so 2x minus 2. G, x minus quantity squared, minus f, x squared minus 2x. G prime, we drop the power, which is 2, x minus 1 to the first power, or over g squared, which is 4, right? So let us do that later. Okay, how can I simplify this one, huh? Let me see. Let us simplify this one. We cannot do anything. How about we factor out x minus 1? Okay, so we factor out x minus 1. Then x minus 1 left. And then 2x minus 1. I'm sorry, 2. And minus, we factor out with the x. How about this? Let us do, let me just do it. Let me just do it. I want to do one step, but anyway. This will be 2x squared minus 2x all over x minus 1 to the fourth power. So this is a 3, and this is gone. So this will be, let's distribute. So there is 2x squared and minus 2x. Okay, there is a negative 2x and negative 2x, which is negative 4x, minus plus 2, minus 2x squared plus 4x. Okay, or over x minus 1 cube. Can you simplify? It's 2 over x minus 1 to the cube, right? So this is the second prime. Okay, let me erase. 2 over x minus 1 cube. So let us do sign analysis again. Step 8. Step 8. Sign analysis. Why I'm using C? Because we're gonna input the critical points. Okay, so critical point. We have x equal to 0 and x equal to 2. F second prime of x, which is 2 over x minus 1 cube. Okay. Now, we're going to input 0 and 2 over 0 minus 1 cube, which is negative, right? This will be negative. Negative means below 0, right? Below 0 means second prime means that concave up, down, sorry. And we are using 2. Okay. This 2 over 2 minus 1 cube. That is positive. Positive means it's greater than 0. Greater than 0 means concave up. Okay, so we're done. So now let us draw. Okay, we are done. Almost. So I'm going to use the line here. Line here. Oh, I was using the line, but it's not line. I cannot use line. Interesting. I can use the horizontal line, but I cannot use the line, the feature for the vertical one. We know that the vertical asymptote at x equal to 1, we know that there is oblique asymptote y equal to x plus 1, right? What else we know? We have y-intercept, x-intercept, 0, 0. What else we know? We remember the f prime sign analysis f prime. I need to take a look. And we should remember the sign analysis. Okay, so first prime gives us a local max, a local minimum. Second prime gives us concave up, concave down, right? All right. The vertical asymptote when x equal to 1. So this is okay. This 1 and oblique asymptote y equal to x plus 1. So y-intercept, which is 0, 1. So this is 1, right? So like that. Oops. Okay, this is the oblique asymptote. This is y equal to x plus 1. Okay. Now, we do sign analysis. Before that, we have a local max. Let me do. When x equal to 0, y equal to 0, we are finding that local minimum at 2, 4. Okay, so 0, 0. Okay, so local max, so shape like this, right? Local minimum, shape like that. Okay, so then this is -1, this point, right? We have a test point -1, right? Earlier, f prime, then it's positive. So we had the positive, going to positive, let me draw. And then there is a vertical asymptote we never touch. So is it good? I want to make it a little bit smoother. I'm not good in drawing. And there's asymptote, vertical asymptote, like that. Okay. Now 2, 4. So local minimum about 2. This is 2. And then 2, 3, 4. This is a 4. 1, 2, 3, 4. Okay, so 2, 4. So local maximum. Okay, I mean minimum, sorry. So this shape looks like this. Okay. So we checked out f of first prime between -infinity to 0 is positive. The slope is positive there, right? Okay, in this part. And then 0 to 1 is negative, slope is negative. Can you see that? Okay. And let's say, when we have 3, x equal to 3 is positive. So this is positive. Okay. Then after 1 is 1.5. 1.5 is negative. The slope is negative. Yeah. Okay. And between -infinity to 1, -infinity to 1. So it's a down there, down graph, right? The second derivative test gives us concave down. So this is concave down. This is concave down, right? And the second derivative test gives us between 1 to infinity is concave up. So this one is concave up. Make sense? I hope this helps you. All right. Thank you for watching. It's a long video. Bye.